Hello students, we studied about irrational numbers in 9th standard. Now revisiting irrational numbers. Here we have one important theorem. 2 is a prime number. 2 divides 8 square. 8 into 8 divided by 2 if we do, we can here divide exactly. And we can understand here 2 divides 8 also. This is what the theorem says. 5 is a prime number. 5 divides 25 square. So 5 divides 25. So what the theorem says, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Now we are going to exercise 1.2. First sum, prove that root 5 is irrational. Here we go for contradiction proof. So we'll write here, let us assume that root 5 is rational. You know that every rational number can be written as a by b, where a and b are integers and b is not equal to 0. That I'll write here. Take root 5 is equal to a by b. Here we take where a and b are co-primes. Co-primes means this a and b are there in the simplest form. Otherwise we can say that there is no common factor for a and b. And b is not equal to 0. Now we are doing here cross multiplication. B root 5 is equal to a. We want to remove this root sign, so we do squaring both the sides. We write like this, b root 5 the whole square equal to a square. So we are getting here 5b square is equal to a square. So we can get here b square is equal to a square by 5. That means 5 divides a square. So our theorem says if there is a p is a prime number, p divides a square, then p divides a also. So here therefore 5 divides a. Since we can divide a by 5, we can take a is a number which is the factor of 5, that is take a is equal to 5 into c. So this one will substitute here in equation 1 from 1 5b square is equal to, in the place of a you write here 5c the whole square. So we are getting here 5b square is equal to 25c square. Divide both the sides by 5. We are getting here b square is equal to 5c square. So c square is equal to, bring this 5 this side, b square by 5. That means 5 divides b square. Therefore 5 divides b. This is what the theorem says. So what we can understand here 5 divides a, 5 divides b. That means a and b both are having at least 5 is the common factor. Therefore a and b have at least 5 as a common factor. But we said that in the beginning a and b both are co-primes. That means they are not having any common factor, we said. So here there is a contradiction. So but this contradicts the fact that a and b are co-primes. And this happened because of our incorrect assumption. This contradiction That means what we are taken in the beginning, it is not proper. We told root 5 is rational. It is not possible. Therefore, root 5 is irrational. To the second sum, prove that 3 plus 2 root 5 is irrational. Here also we are going for contradiction proof. Let us assume that 3 plus 2 root 5 is rational. So every rational number can be written as a by b, where a and b are co-primes and b is not equal to 0. In this case, we consider that we know that root 5 is irrational. So what we do, remaining all the numbers we want to shift over here. So 2 root 5 is equal to, I'll shift 3 this side, a by b minus 3. So take LCM into b, I'll multiply here. So we are getting 2 root 5 is equal to a minus 3b divided by b. So root 5 is equal to a minus 3b by 2b. So here, since a and b are integers, so here a minus 3b by 2b, it is rational. That means root 5 rational. Okay, since that I'll write here. Since a and b are integers, this gives root 5 is rational because both are equal. But this one contradicts the fact that root 5 is irrational. And this contradiction has arisen because of our incorrect assumption. Therefore, whatever we are taken, 3 plus 2 root 5 is irrational. We are going to the third sum. Prove that the following are irrationals. First one is given here, 1 by root 2. Here we are going for the contradiction proof. Let us assume that 1 by root 2 is rational. Since it is rational, we can write as a by b form, where a and b are co-primes and b is not equal to 0. Now, since root 2 is there in the denominator, we rationalize the denominator here. 1 by root 2 multiplied by root 2 and root 2 here is equal to a by b. So we are getting here root 2 divided by 2 is equal to a by b. Doing cross multiplication, we are getting here 2a by b. Since a and b are integers, 2a by b is rational. This gives root 2 is rational. But we know that root 2 is irrational. So this one contradicts the fact. This contradicts that root 2 is irrational. This contradiction is arisen because of our incorrect assumption. Therefore, 1 by root 2 is irrational. Going to the second sum, 7 root 5. Let us assume that 7 root 5 is rational. Take 7 root 5 is equal to a by b, where a and b are co-primes and b is not equal to 0. Here you take this 7 to the other side. Root 5 is equal to a by 7b. Since a and b are integers, a by 7b is rational. This gives root 5 is rational. But we know root 5 is irrational, so it contradicts. This contradicts the fact. This contradiction is arisen because of our incorrect assumption. Therefore, 7 root 5. Going to the third sum, 6 plus root 2. Let us assume that 6 plus root 2 is rational. Take 6 plus root 2 is equal to a by b, where a and b are co-primes and b is not equal to 0. Now leaving this root 2, 6 we want to shift to the other side. Root 2 is equal to a by b minus 6. Take LCM, into b I'll multiply here. So we are getting here root 2 is equal to a minus 6b by b. Since a and b are integers, a minus 6b by b is rational. This gives root 2 is rational. But we know that root 2 is irrational, so it contradicts. This contradicts the fact and this contradiction has arisen because of our incorrect assumption. Therefore, 6 plus root 2 is irrational.